Assalamualaikum warahmatullahi wabarakatuh. My name is Yais, semester 8. I would like to present for the final year project about finite element analysis on tricycle designs. My supervisor's name is Professor Madya Ahmad Kamil bin Hussain. First of all, I would like to start with the overview of this presentation. The first is the introduction. And then we proceed to the problem statement, objective, project scope, methodology, and then result on discussion, and lastly, conclusion and recommendation. Okay, let's start with the introduction. This project is focused on the tricycle frame. Tricycle frame is a frame of a three-wheel bicycle, which is the first tricycle was made by Stephen Fafler, a German man. He is disabled. He cannot use both his legs. For the improvise, so he could move, he invent a mobility transportation which is a hand-propelled tricycle. So tricycle has two different wheel configuration. The first is delta configuration, and another is stateful configuration. The delta configuration is a tricycle that have both two wheels at the back and one wheels at the front. For the stateful is two wheels on the front and one wheels on the back. The advantage of tricycle over bicycle is tricycle is more stable than bicycle when in low speed. Also, tricycle is better suited for load transportation. Okay, for the problem statement is that common tricycle frame is a circular frame, means a circular cross-sectional shape. So choosing another cross-sectional shape may give better strength to the tricycle, so they can carry a lot more load or people on the tricycle. Also, the critical area of the frame is unknown when the load is very heavy. So if the critical area is known, the rider will avoid to load a very heavy object at a certain point. The objective for this project is to determine the critical stress points location on the tricycle frames. Also to make the comparative strength on three different cross-sectional shape design, which is diamond, tubular, and rectangular. The project scope is that the design of the tricycle frames based on the general basic design of stateful configuration, which is two wheels on the front and one wheels on the back. The focus location in this project, the focus analysis in this project is the front side frame of the model, which has a variable cross-sectional shape, which is the tubular in the figure ni, and the diamond, you can see that the diamond, and then the tubular, you can see the other. The analysis project are done in the CATIA V5 static structural analysis. So for the limitation and assumptions, all joints on the frames are in a perfect joint. Also, no ergonomic factor is included in designing the model. Also, the fixed point location is at the socket wheels, two in front on the shaft, and another two is on the back at the wheel socket. Also, the load applied on the frame is determined from the weight of the rider, the weight of the rider when pedaling, and also the weight of the heavy object lifted by the tricycle. The weight of the rider uh, is set on 2000 Newton, which is around 203 kilogram, which is two times uh, two times weight of normal person, which is 100 kilogram. Another one is the force when the rider is pedaling the tricycle, which is the load is set at 3000 Newton, which is very high, uh, so that we can know the model can withstand the 300 Newton for the pedaling. The load of the heavy object is set to be 4000 Newton, which is around 400 kilogram, which is even cars can barely lift up 400 kilogram if the car is concealed. So for the methodology, the first thing is to design the model. We have to design 3 models which has 3 different front configuration, which is the tubular, rectangular, and diamond. And then we set the materials to be steel in CATIA library, which is also known as industrial steel, which is also known as ASTM 836. And then we mesh the models using the standard meshing properties, and then we set the size of the length between the nodes is 5 millimeter. So we set the boundary condition from the previous slides, and then we solve the simulation. So if there is error for the simulation, we diagnose the error and then we fix in the design so that we can get the data result from the simulation. Okay, for the result on this question, the result of the analysis has 2 different data. The first is the von Mises stress on the left side, and the displacement vector on the right side. Also, the critical location that was found are the handle socket and the shaft. Okay, for the von Mises stress at the handle socket, which is the middle of the model frame, the rectangular one has a concentrated value of 320 megapascal, which is caused by the tension of the load at the location. So for the tubular one, it doesn't have any concentrated area comes from the load, from the axial load of at the beam, but it has a more distributed values. Also, the highest value on the socket is about 300 megapascal, which is located at the joint of the handle socket between the bar, the frame bar. So for the diamond, we can see that it also has a concentration when the load is easily forced on the beam. Also, we can focus on the concentration on the joint between the handle socket and the beam. It was the highest at the point, which is around 7.71, which is 771 megapascal, which is already exceeded the maximum allowable stress. This model will fail because it will break, but the other two model will not break because it still under the limit of 400 megapascal, which is the maximum allowable stress for the no, for the steel. Okay, so next location is for the volumetric stress is at the shaft. Okay, the first figures is about the rectangular model. We can see at the shaft, all three shafts has a regular pattern, but the value of each pattern is not the same. We can see the tubular one has a more wide concentration at the end of the shaft, in the middle of the shaft, also for the rectangle, but not as wide as the tubular one. And the diamond one does not have a high value of stress value at the end and the middle of the shaft, like tubular and the rectangle. Okay, this is the bar graph for the comparative uh, maximum volumetric stress on the models. The first one is the rectangular, and the second one is tubular, and the third one is the diamond model. And the white one is the handle socket, and the orange one is at the front shaft of the model. So we can see at the handle socket of the rectangular one, it has a value of around 360 megapascal, which is a high value, but compared to the diamond one, which is around 700 megapascal, which is a very high, which is exceeded the allowable maximum stress. The diamond location, which has the highest concentration of stress, is at the joint between the diamond model to the handle socket. This is a very dangerous area. To avoid this, we need to make it a more curved design. Avoid using the sharp point as the beam to maintain the load, so uh, the load does not concentrated at only one point. Okay, for the shaft, you can see that the diamond has the lowest value, which is around 200 megapascal, which is about the yield stress of the material, which is steel. It will deform a little bit, and then also the same goes to the tubular one. So for the displacement analysis, the pattern for the displacement analysis for all three models is the same, but the value is different. The maximum value I set for all three of them, so that the color contour will be the same standard, is from 0, which is the dark blue one, and 2.28 millimeter for the red one. So we can see that the top figures, which is the rectangular one, has a red value in the middle, which is it has displaced around 2 millimeter, which is quite high for a tricycle. So when moving around on the bumpy road, the load of the heavy object on the tricycle will increase because of the momentum and the gravity. So it will wiggle, and then the wear and tear at the location will increase. So also the same for the tubular one and the diamond one, but the diamond one has the lowest value, which is around 1.6 millimeter, and the tubular one has around 1.7 millimeter of displace. This is the data for the displacement of the rectangular, which is 2.28 millimeter at the middle of the frame. Tubular one 1.77 millimeter, also at the middle, and the diamond one, which is the lowest, is 1.64 millimeter, also in the middle. So for the conclusion, from the analysis, we have determined the critical location of the tricycle, which is at the handle socket and at the shaft, which is very critical. The most critical one is at the handle socket, because it is located at the center of the model, which is need to have a proper amount of support so that can withstand all the load on the tricycle. Another one is although a total of 9,000 Newton load on the tricycle is over design, which is very high, but it is done to ensure the safety factor of the tricycle. But the actual data may vary. Still need to do validation through prototype testing. So the conclusion for the best design is overall design is the tubular design, which has the lowest stress value, and also around 1.77 displacement, which is a low compared to the rectangular one. So for the recommendation, to increase the strength of each of the models, we can increase the thickness of the model, which is the one used in this project is around 3 millimeter, which is quite thin, but the increase in thickness will increase the strength of the model. Also avoid using sub-edges corner to avoid the stress concentration on the joint of the tip of the shape, such as the tip of a star, also a tip of a diamond of the beam. Thank you. That's all from me. If any inquiries happen today, so please contact this number and this email address. Thank you.